Northern Dakota, autumn of 1860. While neighboring Mandan families built standard earth lodge entrances at ground level before winter, Standing Buffalo was still excavating in his eighth week, creating a sloped tunnel that descended 3 feet below the living floor. His fellow villagers called it wasteful labor. The tribal elders shook their heads. Why dig extra when standard doorways had sheltered families for generations? Then the brutal winter of 1861 arrived. Temperatures plummeted to 40 below zero with sustained winds of 50 miles per hour, the deepest cold in living memory that would test every shelter design along the Missouri River. Standard lodge entrances let frigid air blast directly inside, dropping interior temperatures to 20 degrees, while families burned through their wood supplies. But Standing Buffalo's tunnel entrance trapped the dense cold air below floor level, maintaining a steady 50 degrees inside while using 30% less fuel than his neighbors. What did this Mandan builder understand about cold air and Earth's thermal properties that accepted tribal wisdom had overlooked? Standing Buffalo pressed his wooden measuring stick into the soft earth beside the Missouri River, marking the dimensions of what would become the most controversial construction project in his Mandan village. At 42 years old, he had spent 2 decades observing how cold air moved through lodge entrances, watching families shiver as Arctic blasts swept directly across their living floors each time someone opened a door. The cottonwood trees along the riverbank were beginning to shed their leaves in the crisp October air of 1860, signaling the approach of another harsh Dakota winter. His wife, River Willow, watched as he began outlining a trench that would extend 5 feet from their planned lodge entrance, descending 3 feet below what would become their living floor before rising again. She had learned to trust her husband's unconventional ideas over their 18 years of marriage, but even she questioned the extra labor this design would require. Their neighbors were already completing their standard earth lodges, following the time-tested pattern of circular dwellings 30 to 60 feet across with simple vertical doorways facing west toward the prevailing winds. The village elder Iron Willow, at 68 years old, had supervised the construction of more lodges than anyone could remember. He approached Standing Buffalo's work site with a frown deepening the weathered lines around his eyes. "Why make things harder, Standing Buffalo? Our door works fine for 20 families in winters past. This extra digging is wasteful, 3 extra days of labor, more sod to haul. It's foolish." Other villagers gathered to watch the unusual excavation, their voices carrying skeptical murmurs across the autumn air. "The wind will find its way anyway," called out one of the younger hunters. Standing, Buffalo continued his methodical digging, remembering conversations with Hidatsa traders who had mentioned a wind trap vestibule they had observed 2 villages downriver. He had spent the previous winter carefully noting how cold air behaved differently from warm air, watching frost settle in low places while warmer zones remained near the lodge ceiling. His observations had convinced him that dense, frigid air would naturally pool in a depression rather than rushing upward into a living space. Running Fox, a 50-year-old lodge owner whose dwelling stood just 40 paces away, made no attempt to hide his amusement at Standing Buffalo's project. "You'll be digging when I'm resting," he declared loudly enough for others to hear. "Your woodpile will vanish faster than mine." Running Fox had already completed his own 40-foot diameter lodge with a standard entrance, confident that his tried-and-true methods would prove superior to his neighbor's experimental design. As Standing Buffalo and his extended family, including his younger brother Running Bear and their combined households of 12 people, continued their excavation work, they removed approximately 20 cubic feet of earth and sod. The tunnel would measure 2.5 feet in width, with its lowest 0.3 feet below the main floor level and rising to 4.5 feet at the entrance to the living chamber. Standing Buffalo carefully selected 10 cottonwood poles, each 12 feet in length, to support the tunnel's roof structure. The construction process required laying willow rods horizontally, spaced 4 inches apart along the tunnel walls, then covering the entire structure with 3 layers of sod blocks. Each block measured roughly 2 feet by 1 foot by 6 inches, creating a total thickness of 4.5 inches, plus an additional 6 inches of dried prairie grass for insulation. The family worked steadily for 8 days, hauling 300 pounds of willow branches and stacking the heavy sod blocks while their neighbors completed their standard lodges in just 5 days. Wolf Cloud, a 46-year-old builder known for his efficiency, shook his head as he watched Standing Buffalo's laborious process. "You burden your family with more load and more steps. What gain?" Wolf Cloud had built his own lodge using conventional methods, creating a vertical entrance that required no additional excavation or specialized materials. He considered Standing Buffalo's approach unnecessarily complicated and wasteful of both time and resources. Standing Buffalo's quiet persistence stemmed from his careful analysis of previous winter's fuel consumption. He had noticed that his family burned significantly more wood during periods when the door was opened frequently, as each entry allowed frigid air to sweep across their living space. He reasoned that if cold air naturally settled in low areas due to its greater density, a tunnel entrance that dipped below floor level would trap incoming cold air rather than allowing it to flood the main chamber. The completed tunnel featured an outer log flap measuring 4 feet by 6 feet at ground level, leading down into the sloped passage, then rising to an inner entrance measuring 3 feet by 5 feet that opened into the lodge's main living area. Standing Buffalo ensured that the inner floor remained 12 inches above the tunnel's lowest point, creating a thermal barrier that would keep the warmest air in the living zone while allowing dense cold air to settle and remain trapped in the tunnel's depression. As the first snows began to dust the prairie in late October, Standing Buffalo's family moved into their unconventional lodge. They had stockpiled 4 cords of cottonwood for the winter, 1 cord less than the village average of 5, confident that their innovative entrance would reduce heat loss. Their neighbors watched with mixture of curiosity and skepticism, certain that the complex tunnel entrance would prove more trouble than benefit when the brutal Dakota winter arrived in full force. The first test of Standing Buffalo's controversial design arrived on November the 14th, 1860, when nighttime temperatures plummeted to 10 degrees below zero across the Dakota plains. A high-pressure system from the Arctic pushed frigid air southward, and by November 20th, daytime temperatures struggled to reach 15 below, while nights dropped to 35 below zero. Sustained winds of 40 miles per hour, gusting to 60, created wind-chill conditions that made exposed flesh freeze within minutes. Running Fox discovered the harsh reality of conventional lodge design during the 3rd day of the cold front. Each time someone in his family needed to step outside for firewood or personal needs, the heavy log door required significant effort to open against the wind pressure. When family members returned, torn gusts of Arctic air rushed directly across the living floor, instantly dropping the interior temperature. Running Fox began measuring his wood consumption carefully, burning 11 pounds per hour compared to his typical 8 pounds during normal winter conditions, a 30% increase that threatened to exhaust his fuel supply before spring. The interior floor temperature in Running Fox's lodge, which normally maintained a comfortable 50 degrees near the central fire pit, plummeted to 20 degrees within 2 hours after each door opening. Cold drafts created ice formations along the outer walls where moisture from cooking and breathing condensed and froze. The buffalo hide bedding nearest the walls became stiff with frost, and Running Fox's 2 youngest children, ages 4 and 6, began complaining of numbness in their fingers and toes, despite wearing thick fur mittens and boots. Standing Buffalo's tunnel entrance functioned exactly as he had predicted. When family members needed to venture outside, they opened the outer log flap and stepped down 3 feet into the tunnel's lowest section. The heavy flap could then be closed behind them, sealing the main living chamber from direct wind exposure. Upon returning, they followed the same process in reverse, entering the tunnel, closing the outer flap, then climbing the gentle rise into the warm living area. This sequence prevented the catastrophic heat loss that plagued conventional entrances. The tunnel's design exploited fundamental principles of air density and thermal mass that Standing Buffalo had observed through years of careful attention to natural phenomena. Dense, frigid air entering through the outer flap naturally settled in the tunnel's lowest section, 3 feet below the main floor level, rather than rushing upward into the living chamber. The packed earth walls surrounding the tunnel, measuring 2 to 3 feet in thickness, absorbed heat from the lodge's interior and slowly released this thermal energy into the tunnel space. Incoming air, initially at 20 degrees below zero, warmed to approximately 10 degrees above zero as it passed along these earth walls before reaching the living area. Standing Buffalo's family maintained their interior temperature at 55 degrees, while burning only 7 pounds of wood per hour, 12% less than their original estimates and 45% less than Running Fox's consumption. The thermal stratification within the lodge kept warm air concentrated in the living zone, while cold air remained trapped in the tunnel depression, creating distinct temperature layers that prevented mixing of warm and cold masses. Wolf Cloud's lodge experienced similar problems to Running Fox's dwelling. The direct entrance allowed wind-driven cold air to sweep across the floor each time the door opened, creating a convection current that pulled warm air toward the entrance and out of the lodge. Wolf Cloud found himself adding extra logs to his fire every hour, watching his carefully calculated fuel supply disappear at an alarming rate. Frost began forming on the inner surfaces of his lodge walls, where the sod covering couldn't prevent heat loss through thermal bridging at the wooden structural members. The village's other conventional lodges showed similar patterns of excessive fuel consumption and interior temperature drops. Families huddled closer to their central fire pits, wearing extra layers of clothing indoors and burning through their wood stockpiles at unprecedented rates. Children in several lodges developed early signs of cold stress, including persistent shivering and difficulty maintaining body heat despite adequate clothing and bedding. By the 7th day of the severe weather front, Running Fox could no longer ignore the dramatic difference between his lodge's performance and Standing Buffalo's. His family's sleeping furs had become so cold and stiff that they provided little insulation, and his food storage containers near the walls had begun to freeze, causing dried corn to crack and stored fat to become too hard to use for cooking. The constant struggle to maintain interior warmth had exhausted his family both physically and mentally. Standing Buffalo's family, meanwhile, continued their normal winter routines with minimal disruption. Their food storage remained at proper temperatures, their bedding stayed warm and flexible, and their daily wood gathering provided adequate fuel without the desperate urgency experienced by their neighbors. River Willow continued her regular cooking schedule, preparing meals over a fire that required only routine maintenance rather than constant feeding. When Running Fox finally approached Standing Buffalo's lodge on the evening of the 7th day, swallowing his pride and admitting the superiority of the tunnel design, he found a family living comfortably despite the brutal conditions raging outside. The contrast between the two lodges' interior conditions provided undeniable proof that Standing Buffalo's innovative entrance design had solved a fundamental problem that conventional Mandan architecture had never adequately addressed. The storm that had exposed the limitations of traditional methods was about to break, but its lessons would reshape lodge construction throughout the village for generations to come. The brief respite from Arctic conditions ended abruptly on January 5th, 1861, when an even more severe weather system descended upon the Missouri River Valley. This prolonged cold snap would test every structure in the village for 46 consecutive days, with daytime temperatures struggling to reach 20 degrees below zero and nighttime lows plunging to 40 below. Snow accumulated in drifts reaching 4 feet in height, driven by relentless winds that maintained speeds of 30 to 50 miles per hour throughout the ordeal. Running Fox's lodge, already weakened by the earlier cold front, began showing signs of structural failure within the first week of the extended freeze. On January 10th, his family discovered that the door flap had frozen solidly to its wooden frame, sealed shut by layers of ice that had formed from their own breath and cooking moisture. Running Fox was forced to use an axe handle to wedge the entrance open, a process that required keeping the door wide for 30 seconds while he chipped away ice formations. During these extended openings, the interior temperature dropped from 15 degrees to near zero, creating conditions that threatened hypothermia for his youngest family members. 2 of Running Fox's children developed frostnip on their toes, despite wearing thick fur boots and remaining close to the fire pit. The family's food storage, elevated on wooden platforms above their sleeping benches, began freezing solid as the interior temperature could no longer be maintained above the critical threshold. Dried beans cracked from repeated freeze-thaw cycles, and stored corn became so brittle that it shattered when handled. Running Fox's fuel consumption increased to 12 pounds per hour, 50% higher than Standing Buffalo's steady rate, rapidly depleting his remaining wood supplies. Wolf Cloud's 35-foot diameter lodge experienced even more severe structural problems as the prolonged cold continued. The sod walls, constructed using traditional methods with gaps between the wooden frame and earth covering, began experiencing frost heave as ground moisture expanded during the freeze. The outer sod layer displaced inward by 6 inches over several weeks, creating a half-inch gap between the log framework and the insulating earth layer. This thermal bridge allowed continuous heat loss and created a measurable cold air infiltration of 0.3 of a cubic foot per minute whenever the door was opened. Small cracks appeared in Wolf Cloud's log frame near the floor level, allowing additional cold air penetration that his family attempted to seal using buffalo hide patches. Despite these emergency repairs, his lodge's interior temperature dropped to 15 degrees, forcing the family to abandon their normal sleeping arrangements and crowd together near the central fire throughout the night. Wolf Cloud's carefully calculated fuel supply dwindled to 2 8/10 cords by mid-February, well below his planned reserve of 4 cords for the final month of winter. Standing Buffalo's tunnel entrance proved increasingly valuable as the crisis deepened. When wind-blown snow blocked the outer tunnel entrance on January 12th, his family developed an efficient clearing procedure that minimized heat loss. Rather than opening the main door wide to shovel drift, they removed only enough snow to access the outer tunnel flap, stepped into the tunnel chamber, closed the outer entrance, then cleared additional snow from inside the protected space. This method maintained the tunnel floor temperature at 10 degrees below zero while keeping the living chamber at a steady 48 degrees. The thermal performance of Standing Buffalo's design improved during the extended cold period due to the increased temperature differential between inside and outside conditions. The earth mass surrounding the tunnel walls absorbed more heat from the interior space and released it more effectively to incoming air as the exterior temperature dropped. The greater the temperature difference, the more pronounced the pre-warming effect became. Air entering at 30 degrees below zero consistently warmed to near 10 degrees above zero by the time it reached the living area. Standing Buffalo's family maintained their fuel consumption at 7.5 pounds per hour throughout the extended crisis, burning a total of 8 6/10 cords over the 46-day period compared to their original estimate of 10 cords. Standard lodges in the village averaged 13 to 15 cords during the same period, with some families completely exhausting their supplies and requiring emergency assistance from neighbors. The food storage system in Standing Buffalo's lodge remained stable due to the consistent interior temperature. River Willow's cache pit, lined with willow rods and measuring 4 feet deep with a 2-foot diameter, maintained an internal temperature of 35 degrees, while the ground outside registered 5 degrees. The beans, corn, and dried squash stored in grass-lined containers remained dry and usable throughout the crisis, providing reliable nutrition when other families faced spoilage and waste. Wolf Cloud's deteriorating situation forced him to make a difficult decision on January 20th. He approached Standing Buffalo's lodge during a brief lull in the wind, noting immediately the absence of ice formations around the entrance and the minimal snow accumulation near the outer tunnel flap. When Standing Buffalo invited him inside, Wolf Cloud was struck by the dramatic temperature difference: 47 degrees in Standing Buffalo's living chamber compared to 15 degrees in his own lodge that same evening. The contrast was undeniable. While Wolf Cloud's family huddled in fur wrappings around a fire that consumed wood at an unsustainable rate, Standing Buffalo's family conducted normal winter activities in comfortable warmth. The tunnel entrance had transformed from an object of ridicule into a sophisticated engineering solution that addressed fundamental problems in cold weather shelter design. Wolf Cloud's quiet admission that he would adopt the tunnel design marked a turning point in the village's understanding of thermal efficiency and structural innovation. The brutal winter's climax arrived on February 15th, when temperatures plunged to their lowest point of the entire season. 40 degrees below zero with sustained winds created conditions that tested not only the Mandan lodges, but also the Euro-American frontier structures that had appeared along the Missouri River Valley. A recently constructed wooden cabin, built by settlers using traditional European methods, provided a stark comparison to indigenous shelter technology during this extreme weather event. The frontier cabin, constructed with straight wooden plank walls and a simple hinge door, faced catastrophic heat loss when the occupants needed to retrieve supplies from their outdoor storage shed. The cabin door, measuring 4 feet wide and 7 feet tall, opened directly into the single-room interior without any protective vestibule or wind barrier. When opened for a routine supply run, the 40-degree below zero wind burst through the doorway like a frozen river, instantly overwhelming the cabin's heating system. Within 45 minutes of the door opening, the interior temperature dropped from 44 degrees to 10 degrees, despite a roaring fire in the iron stove. The settlers were forced to burn 18 pounds of wood per hour to maintain temperatures above 30 degrees, more than twice Standing Buffalo's consumption rate. The cabin's thin wooden walls, lacking the thermal mass of earth construction, provided minimal insulation against the penetrating cold and allowed rapid heat transfer to the exterior. Meanwhile, Running Fox's conventional lodge continued its struggle against the extended freeze. His fuel reserves had dwindled to 2 8/10 cords from his original stockpile, well below the 4 cords he had planned to reserve for the final month of winter. The interior temperature in his lodge had stabilized at a dangerous 15 degrees, forcing his family to wear all their winter clothing indoors and maintain constant vigilance over their fire to prevent it from dying during the night. The structural integrity of Running Fox's lodge showed visible signs of stress from the prolonged cold exposure. Frost heave had pushed sections of the outer sod wall inward by 6 inches, creating gaps between the wooden framework and the insulating earth layer. These thermal bridges allowed continuous cold air infiltration, and Running Fox's family was forced to stuff buffalo hide strips into the expanding cracks. Despite these emergency repairs, a half-inch gap remained between the logs and sod layer, creating a measurable heat loss that compromised the entire structure's efficiency. Standing Buffalo's lodge demonstrated remarkable stability throughout the final phase of the crisis. The tunnel entrance continued to function as designed, with the outer flap system preventing direct wind penetration into the living chamber. His family's fuel consumption remained steady at 7.5 pounds per hour, and their interior temperature held at 47 degrees, 32 degrees warmer than Running Fox's lodge during the same measurement period. The thermal mass effect of Standing Buffalo's tunnel design became most apparent during the extreme cold conditions. The earth walls surrounding the tunnel passage, measuring 2 to 3 feet in thickness, had absorbed heat from the lodge interior throughout the winter and now released this stored thermal energy more efficiently as the temperature differential increased. Air entering the tunnel at 40 degrees below zero consistently emerged into the living chamber at approximately 10 degrees above zero, representing a 50-degree temperature increase through passive solar gain and thermal mass interaction. Food preservation in the conventional lodges reached critical failure points during February's extreme conditions. In Wolf Cloud's lodge, stored provisions above the sleeping benches froze solid, causing dried beans to crack and rendering stored animal fat too hard for cooking purposes. The temperature fluctuations from repeated door openings created freeze-thaw cycles that destroyed the cellular structure of dried vegetables and compromised the nutritional value of their winter food supplies. Standing Buffalo's family continued to benefit from stable food storage conditions throughout the crisis. River Willow's cache pit system maintained consistent temperatures that kept stored provisions in optimal condition. The tunnel entrance's superior thermal performance eliminated the temperature swings that plagued conventional lodges, preserving food quality and ensuring reliable nutrition during the most challenging period of the winter. The contrast in structural performance became undeniable as the crisis reached its peak intensity. While standard lodges showed signs of mechanical failure from frost heave and thermal stress, Standing Buffalo's design remained structurally sound. The tunnel entrance had prevented the wind-driven moisture infiltration that caused ice formation and expansion damage in conventional doorways. His outer log framework showed no measurable gaps or displacement, maintaining the original construction tolerances despite months of extreme weather exposure. Village elder Iron Willow, who had initially dismissed Standing Buffalo's innovation as wasteful labor, made a formal visit to assess the tunnel entrance's performance during the final week of February. At 68 years old, Iron Willow had experienced more brutal winters than any other member of the community, and his engineering judgment carried significant weight in lodge construction decisions. When he measured the interior temperature difference between Standing Buffalo's lodge and conventional structures, the evidence was irrefutable. Standing at the threshold of Standing Buffalo's warm, stable living chamber, while wind howled outside at 40 degrees below zero, Iron Willow acknowledged the fundamental superiority of the tunnel design. His quiet admission represented more than personal recognition. It marked the moment when individual innovation overcame traditional skepticism through demonstrable performance under extreme conditions. The crisis that had threatened to exhaust fuel supplies and compromise survival had instead validated Standing Buffalo's understanding of thermal dynamics and cold weather shelter engineering. The winter of 1860 to 61 was ending, but its lessons would reshape Mandan Lodge construction for generations to come. The spring thaw of 1861 brought more than seasonal relief to the Mandan village along the Missouri River. As temperatures rose above freezing for the first time in months, families emerged from their lodges to assess winter damage and begin planning reconstruction projects. The dramatic performance differences between conventional and tunnel entrance designs during the brutal winter had fundamentally shifted community attitudes toward lodge construction methods. Standing Buffalo found himself in the unprecedented position of technical consultant as village leaders organized a formal meeting in April to discuss lodge building standards. 12 families attended the gathering, representing the core group of skilled builders who would influence construction practices for the entire community. 8 families, including Running Fox and Wolf Cloud, formally requested detailed instruction in tunnel entrance design and construction techniques. The community's most experienced woman builder, Sage Buffalo, at 60 years old, had supervised lodge construction for over 4 decades and commanded deep respect for her architectural knowledge. She approached Standing Buffalo with a formal request to document his tunnel design in the construction records that guided new builders. Her endorsement carried significant weight because she had initially permitted his experimental approach with considerable skepticism, warning that structural failure could endanger entire families. Standing Buffalo agreed to demonstrate his construction methods using a practice excavation site near the village gathering area. He began by showing the precise excavation technique required for the tunnel entrance, emphasizing that the depth and slope angles were critical to the design's thermal performance. The tunnel measured 2.5 feet in width and 5 to 6 feet in length, with the crucial 3-foot descent below the planned floor level that created the cold air trap. The horizontal willow rod framework required careful spacing at 4-inch intervals to provide adequate support for the sod covering while allowing thermal conduction through the earth walls. Standing Buffalo demonstrated the selection process for cottonwood support posts, choosing 12-foot lengths that provided structural integrity for the tunnel roof while accommodating the sloped design. The 10 support posts needed to be positioned at specific angles to distribute weight evenly across the tunnel span. River Willow joined the instruction session to explain the sod layering technique that created the tunnel's thermal mass. Each sod block measured approximately 2 feet by 1 foot by 6 inches and required careful positioning to eliminate gaps that could compromise insulation. The 3-layer stacking method created a total earth thickness of 4.5 inches, supplemented by 6 inches of dried prairie grass that provided additional thermal buffering. The critical elements of door construction demanded precise attention to dimensional relationships. Standing Buffalo showed how the outer log flap at tunnel base measured 4 feet by 6 feet, while the inner flap at the living chamber entrance measured 3 feet by 5 feet. The size difference ensured proper airflow management and prevented pressure imbalances that could compromise the thermal barrier effect. The inner floor elevation, positioned 12 inches above the tunnel's lowest point, maintained the temperature stratification essential to the design's performance. During the summer building season of 1861, 6 new lodges incorporated tunnel entrances based on Standing Buffalo's specifications. The builders made minor modifications to accommodate different soil conditions and family size. Requirements with tunnel lengths ranging from 5 to 7 feet and some variations in depth depending on drainage considerations. The average lodge diameter remained consistent at 38 feet, but the enhanced thermal efficiency allowed families to reduce their planned fuel stockpiles. Running Fox completed his new lodge with a tunnel entrance measuring 6 feet in length and featuring improved drainage channels to prevent water accumulation during spring thaws. Wolf Cloud incorporated a slightly wider tunnel design at 2 3/4 feet to accommodate his larger family size, while maintaining the critical depth and slope relationships that created the thermal performance advantages. The documentation process established by Sage Buffalo created a permanent record of tunnel construction techniques that could be transmitted to future generations. Her construction manual included specific measurements, material requirements, and seasonal timing considerations that ensured successful implementation. The manual noted that excavation should begin in late spring when soil conditions allowed efficient digging, with completion scheduled before autumn. Weather made outdoor construction difficult. By the late 19th century, when many Mandan families transitioned to timber frame housing, archaeological evidence at the Knife River site revealed the widespread adoption of subterranean entrance features. Excavation's uncovered tunnel remains measuring 4 to 6 feet in depth and 5 to 7 feet in length, confirming the persistence of standing buffalo's innovation throughout the final decades of traditional lodge construction. The thermal principles demonstrated by standing buffalo's design influenced broader understanding of earth-sheltered architecture among both indigenous and European American builders in the region. Modern studies of passive solar design and thermal mass applications validate the scientific accuracy of his observations about cold air density, earth thermal storage, and airlock vestibule effects in extreme climate shelter design. Standing Buffalo's quiet revolution in lodge entrance design represented more than individual innovation. It demonstrated how careful observation of natural phenomena, combined with willingness to challenge conventional methods, could produce superior survival technologies. His understanding that cold air falls while warm air rises, that Earth stores and releases thermal energy, and that gradual transitions prevent sudden temperature shocks had created a shelter system perfectly adapted to the harsh realities of Dakota winter survival. The legacy of his tunnel entrance design extended far beyond the immediate community, becoming part of the permanent indigenous knowledge base that would inform cold weather shelter construction for generations of builders who understood that survival often depended on recognizing what nature had always been teaching those wise enough to observe and adapt.